Welcome back to the Caribou Data Science channel. Or I should say, welcome back to your Caribou Data Science channel, because this channel is all about you. Everything I do is for you. Okay? So that's why I appreciate every single one of you 76 people who have subscribed. I'm thankful for all you dozens of people who have liked, say, the Swedish videos or the Israel videos. Thanks so much for those also. I'm just going to continue to take a look at the data here. Okay? We're going to continue to look at the countries, at some countries here. So the last one we've done is California. So let's do states by population. Did I do Virginia? Georgia. I thought sure I did. Sure I did New Jersey. Okay. So let's add one more state then after California. That's not right. Georgia, Ohio, Georgia, Michigan. So it looks as if Georgia is. You know, I'm probably doing. I'm probably looking at the wrong thing here. Here we go. New Jersey. I thought sure I may have done. Okay, but let's come back up here. I'm going to get rid of some of the code. No, we're not, are we? That's right. We're going to keep all the states here together. There we go. So let's come down here. Cases, cases, cases. California, Georgia, New Jersey. So let's do this. Let's just add Virginia. You know, I think of what Diogenes the Cynic was alive today, you probably have trouble finding an honest COVID-19 number, okay? Where's that? Okay, let's come all the way back down here now. Once again, New Jersey. Let's come back up here, check Virginia again. Okay, let's take a look at this now. See if this will run. We're only going to take a look at the new additions to this report. Okay, so now we have Virginia down there someplace, and now we have Virginia. Deaths split out by state. Okay, daily deaths split out. Let's come all the way down there till we find Virginia. Virginia. Okay, so you can see that their cases, okay, are are a little below what's expected, 27.17. Okay, so once again, cases. Well, let's come down and see what. Okay, hopefully my theory isn't wrong. That if New York is wrong, because if New York, if that really, if we really could say there's a high probability that New York's numbers are wrong. And this is what the Benford analysis looks like for New York deaths first digit. So that means anything similarly, okay, similarly is also wrong. Okay, because this is 0.073. This isn't even 1%, and that just can't be right. Can it really be that far off for deaths? I don't know, folks. This is getting, I really don't know. It will be interesting to see what, of course, it was Washington State where where it all began. So let's come down here. Ohio, New Jersey, New Jersey, North Carolina, Michigan, New Jersey, Virginia. Let's come back down here. Let's add Washington to this. Washington. So let's see if this will run by itself. So let's come all the way down to here now. Even though technically it's deaths, the actual data frame name is cases. It saves us the problem of constantly renaming some files. So let's come back and take a look at Washington State. No, it's called reproducible. I was really happy that Carlos actually took the time to write back to me not once but twice. Okay, it's going to be really interesting to see whether he thinks we can sort of compare New York's uh, Benford analysis plots with, say, other states to look for possible problems. Okay, so let's come back up here. So now you can see Washington State and Washington State. Okay, interesting. Those look identical to me. 1500, 2000. Okay. Deaths, Washington deaths. Let's make sure we're actually getting this correct. No, we're not, are we? Crap. No wonder they look so close. Let's make sure we came back up here also. Okay. So that's a little better. So for the time being, I'm simply going to describe this as being a data visualization or data exploration numbers, okay? So now I come back over here, Worship. You can see this. We notice there's two different data. This has a 1500. This has 2500. So we know that as close as they are, they're still not the same thing. Now, what about deaths? Once again, 1500, 2000. So as close as these look, they are a little different. Deaths by state. Okay. Now scroll all the way down here to Washington. Washington. Now here you can see that while the cases is closer to fitting Benford's law, it's still only 22%. Let's come down to cases, or deaths, I mean. Virginia. Once again, this is 8%. This is the expected numbers. This is the actual numbers. You wonder if anybody's actually uh, you wonder if anybody's actually telling the truth. Hopefully, I hate to say it, but hopefully, when Carlos looks at it, he may say, well, you really can't use this to prove or to predict whether or not the state's actually cheating or not. Because otherwise, some of these states have a serious data quality issue. Okay, if we can use New York State's COVID-19 analysis for for as an example of uh, fraud, okay, if we can come with a 90% chance that that based on Benford's law we can that New York State is understating its deaths at some point, then that means that any plot for other states' deaths that are similar to New York, similar in that they're less than expected, then that means there's a high probability that they may be fudging their numbers also. And I certainly hope that's not the case. I guess the thing that bothers me about this potential most of all is that we had a once in 100-year opportunity here to really study a pandemic, not only U.S. but a worldwide pandemic. And if we got if we got and if we got states that are for the most part are cheating, then we've lost the once in 100-year opportunity to really study a pandemic. Okay, that's really my concern here. Okay, so today's report's going to end with Arizona. So we've done what Virginia, Arizona, Virginia, Washington, and Arizona, right? We are doing this, by the way, in the order of population. That's why it's not alphabetical. So let's come all the way down here. While we're down, we might as well do this backwards then, right? Arizona. Well, this is deaths, and again, the deaths are below the expected values for the data set. Now, I want you to notice here. Look how close cases is to expected values. So in some cases, in some instances, the cases are fairly close. But again, deaths are not close. So what we got? Okay, so this concludes the reports for Virginia, Washington, and Arizona. Okay, thanks so much for your time. By the way, I want to remind you that this is your channel. Okay, this is our channel, and I'm here to assist you to help you understand COVID-19, among other subjects. Okay, but really it's about COVID-19, using various methods, focusing on our programming and use basic data visualization. And now we're using a specialized data visual analysis tool called Bedford's Law. Okay, so as always, don't forget to subscribe to the Caribou Data Science channel. Share the Caribou Data Science channel with one of your friends this week. And also click on the like button and click on the share button. We could reach 80 subscribers this week if every one of you starts sharing this channel and this video with one other person this week. All right. Thanks so much for your time, and we'll catch you on a later report.